What specific problem does the new method address in the field of language model evaluation?
The new method addresses the problem of limited flexibility and weak evaluation performances of open evaluator language models, LMs, in handling diverse real-life scenarios and in effectively simulating human judgments or those made by proprietary LMs. The method aims to bridge the gap by unifying the two model-based evaluation paradigms, direct assessment and pairwise ranking, to train a robust unified evaluator LM. By merging the weights of evaluator LMs separately trained on direct assessment and pairwise ranking formats, the new method creates a unified evaluator LM that excels in both schemes and outperforms existing open evaluator LMs. This approach enhances the evaluation capabilities of open evaluator LMs, making them more versatile and effective in assessing LM-generated text across various tasks and scenarios.
How does the proposed method of weight merging in evaluator LMs work? Please illustrate the step-by-step process.
The proposed method of weight merging in evaluator LMs works by training two separate evaluator LMs on direct assessment and pairwise ranking feedback datasets. First, two base models, Mistral 7B and Mixtral 8x7B, are separately trained on the feedback collection and the preference collection datasets. Then, the weights of these evaluator LMs are merged using a linear merging technique with a coefficient alpha set to 0.5. This merging process combines the strengths of both models to create a unified evaluator LM, named Prometheus 2, 7B and 8x7B, that excels in both direct assessment and pairwise ranking evaluation schemes. The weight merging approach outperforms other methods such as joint training, as it shows positive task transfer and improves evaluation performances significantly. Additionally, the weight merging process involves techniques like task arithmetic merging, ties merging, and DARE merging, which aim to resolve disagreements and remove redundant weights in the task vector to enhance the overall performance of the resulting evaluator LM.
What are the theoretical benefits of unifying direct assessment and pairwise ranking in evaluator LMs, as proposed in the paper?
The theoretical benefits of unifying direct assessment and pairwise ranking in evaluator LMs, as proposed in the paper, include the ability to handle diverse real-life scenarios effectively. By merging the weights of two evaluator LMs, trained separately on direct assessment and pairwise ranking formats, a robust unified evaluator LM is obtained. This unified LM not only works in both direct assessment and pairwise ranking formats, but also outperforms evaluator LMs that are jointly trained or only trained on a single format. The unified evaluator LM, such as Prometheus 2 models, demonstrates high correlations with both human evaluators and proprietary LM-based judges on both direct assessment and pairwise ranking. This unification allows for a more comprehensive evaluation process that excels in both assessment schemes, providing a more accurate and reliable evaluation of LM-generated text. Additionally, the unified evaluator LM can handle a wider range of evaluation criteria beyond generic qualities like helpfulness and harmlessness, making it more flexible and adaptable to different evaluation needs.
How were the Prometheus 2 models validated in the experiment?
The Prometheus 2 models were validated in the experiment by comparing their performance with human evaluators and proprietary LM-based judges on both direct assessment and pairwise ranking benchmarks. The validation process involved assessing the correlation of the Prometheus 2 model's scoring decisions with those of human evaluators and proprietary LMs, such as GPT-41106 and Claude 3 Opus. The Pearson correlation coefficients were used as the primary metric to measure the level of agreement between the Prometheus 2 models and the human evaluators or proprietary LMs. The results showed that the Prometheus 2 models consistently outperformed existing open evaluator LMs, demonstrating higher correlations with human evaluators and proprietary LM-based judges across all datasets. Additionally, The Prometheus 2 models were evaluated on both direct assessment benchmarks, such as Vicuña Bench, Mount Bench, Flask, Feedback Bench, and pairwise ranking benchmarks, including HHH alignment, Mount Bench human judgment, AutoJ eval, preference bench, showcasing their ability to excel in both evaluation formats. The Prometheus 2 models exhibited the highest agreement with human evaluators among all the Open Evaluator LMs tested, effectively reducing the performance gap with GPT-4 by half on the pairwise ranking benchmarks.
What were the specific results achieved by the Prometheus 2 models on both direct assessment and pairwise ranking benchmarks compared to existing Open Evaluator LMs?
The Prometheus 2 models achieved the highest correlation with both human evaluators and proprietary LM-based judges on direct assessment benchmarks, surpassing other baselines by 0.2 units across all datasets. Specifically, on benchmarks such as Vicuña Bench, Mount Bench, Flask, and Feedback Bench, the Prometheus 2 models demonstrated strong correlations with human evaluators and proprietary LMs, outperforming existing Open Evaluator LMs. On pairwise ranking benchmarks like HHH alignment, Mount Bench, human judgment, AutoJ eval, and preference bench, the Prometheus 2 models also showed the highest agreement with human evaluators among all the Open Evaluator LMs tested, effectively reducing the performance gap with GPT-4 in half. These results indicate that the Prometheus 2 models excelled in both direct assessment and pairwise ranking evaluations, scoring high correlations with human evaluators and proprietary LM-based judges compared to existing Open Evaluator LMs.
What are the limitations or drawbacks of the weight merging approach in training unified evaluator LMs, according to the paper?
The limitations or drawbacks of the weight merging approach in training unified evaluator LMs, as outlined in the paper, include the fact that merging evaluator LMs trained on the same evaluation format does not necessarily improve evaluation performances. Specifically, when two evaluator LMs trained on direct assessment formats or pairwise ranking formats are merged, the resulting evaluator LM may not show improved performance and could even harm performance on average. This suggests that simply ensembling multiple models trained on the same evaluation format may not lead to better results. Additionally, the weight merging approach may require careful consideration of the coefficient alpha used in the linear merging process. The optimal alpha value may vary, depending on the specific benchmarks and metrics being used, which could introduce complexity and require fine-tuning for different scenarios. Furthermore, the weight merging approach may not fully address all challenges related to training unified evaluator LMs, such as ensuring robustness across diverse real-life scenarios and handling fine-grained evaluation criteria beyond general public preferences.